In this video, we're going to work with manipulating spatial data. So work with search cursors. So cursors are used to iterate over the rows in a table. Cursor functions create cursor objects, which can be used to access the row objects, and several methods exist to manipulate this row objects. We're going to do the search. Cursors are used to search records to carry out SQL expressions in Python. So, as always, we will bring everything up ArcMap, and I will type Python win. So now we start ArcMap and we open a new, going to do a new blank map. And then we still have our Arc catalog window here. So let's go to Python, and then we will do data, and it's exercise 7. And then we're going to do is we have the airports shapefile. I'm going to drag it here. It's very important. Last time, if you don't drag it, then when you run your Python code, your data is not there. So, all right. And we're going to do is right click on the airports, open attribute table, and we're going to examine the fields. We do have feature ID, and notice the name is notice that we have name here, and the field contains 221 records. So now we are in Python win, and we're going to create a new script, and I'm going to save it. Data exercise 7. This one we will call it print values. And now I have to put my code. I do want to bring everything back from the previous exercises. Data exercise 6, either of them, and I want my path. Copy and then close it out. Okay, so I have import ArcPy. From ArcPy, import environment, and environment workspace equals to my 07 function equals to airports shapefile. Oopsies. Cursor, and I have ArcPy data search cursor function, and then oopsies, name, for a row in cursor. No. Print, and then just one print airport port name equals 0 dot format row 0. All right, now we notice that the script creates a search cursor on the feature class and use for loop to iterate over all the rows of the attribute table. Now I'm going to save it and check. Run. Oh, okay. Now, for row in cursor. For row in cursor, that's fine. Print airport name. Square, angle brackets, square, brackets, curly brackets, import ArcGIS. From ArcGIS import environment. From ArcGIS import environment. Environment workspace. Oh. Workspace. And then airport shapefile. And cursor. There. Cursor, ArcGIS, not ArcPay. ArcGIS. Data, search cursor, function name, and I need to close it out. For row in cursor, print airport name equals 0 format. Alright, looks good. Click save and then click check again. Run. Perfect. So now, previously we had the challenge task. How would you print out something? Then you import something, cursor equals something, and then in a row that you can print some stuff using that sentence. Alright, and then we're going to use search cursor with SQL in Python. And now we will do is open a new, and then in Python we have a new script, and we're going to save it. File, save as, back in exercise 7, called it SQL. And now we have the window here. We're going to input everything. So import ArcGIS, and from ArcGIS we will import environment. And then environment workspace equals, we will put our path name 07, function equals to airports shapefile, and then cursor equals ArcGIS dot search cursor, and function comma name comma top underscore emp greater than 1, 2, 3, 4, 5. How many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, I have a 5. And I need a single quotation mark. The end. Alright, and for row in cursor, print row 0, delete row, and delete cursor. And then I'm going to save it and check it. Successfully checked. Now I'm going to run. Perfect. Okay, let's see. Alright. There we have the result list names of the airports for which the SQL expression is true. The top EMP, the field top EMP is a measurement of the number of passengers that we have listed here. Let's see if it will load in here. Passengers, EMP top passengers. All right. So, oh, I should just top 10. All right. Yep. Scroll back. 1, 2, 3, 4, 5, 6, 7. Top Canal, Bethel, Kitchener, Juneau, and then okay. That's the airport. So, Sheffield, Alaska. All right. Okay. And I'm going to load SQL. All right. Let's load. All right. So that's the top 1, 2, 3, 4, 5. It's just like SQL. All right. So we take another look at the SQL expression. It's right here. And used top EMP that it's greater than 10,000 field delimiters for shapefiles consist of double quotation marks. For example, top but there are no quotation mark around the value of 10,000 because top EMP is a numeric field. The entire SQL expression needs to be in quotation marks because the where clause in the syntax of the search cursor is a string. This results in the SQL expression top EMP 10,000. Oh, 100,000, sorry. So the syntax can create complications. For example, for text field in SQL expressions, the value requires single quotation marks. For example, name equals Ketchikan. The statement in the where clause needs to be in quotation marks, but whether you use double quotation marks or single quotation mark, the statement will produce a syntax error. The solution is to use the escape character, so which would otherwise cause a syntax error in front of the quotation marks. So in Python, a backlash within a string is interpreted as an escape character, which is a signal that the next character is to be given a special interpretation. So instead of name Kitchkan, the expression becomes name Kitchkan. So that we have to put backslash. So now we're going to modify the SQL. Instead of here, I will have a cursor occupied the search data cursor function. Here I will do name function. I have a name, and then inside of it, it will be I have to put single quotation mark feature equals to backslash single C plain base backslash and another single quotation mark, and then save, and then check, and then run, click OK. And that we will have, let's just code A. Let's run again then. Then we will have a hinder. The results is a list of the names of the airports. For the SQL expression, it is true that we have this much. So there are other complications when working with SQL expressions. Specifically, the field delimiters vary with the format of the feature class. So shapefile and file geodatabase feature classes use double quotation marks, for example, name. Personal geodatabase feature classes use square brackets,